Okay, so today we are going to continue that in-class exercise that we didn't finish last time, the bond problem from in-class exercise 16. But before we get to that, just a reminder that your next homework assignment, homework 6, is due on Monday. And then the project is due on November 19th. And then another announcement is that online class for Monday. So we won't be meeting in person for class on Monday. And in fact, I've already recorded and posted the video for that. It's available on YouTube right now. I have an announcement scheduled as a reminder. It'll come to you on Sunday, a reminder that we don't have an in-person class meeting on Monday. So does anybody have questions related to the announcements? We're going to do an in-class exercise today that I think will give you the remaining pieces of the puzzle for homework number 6. So let's revisit that bond problem, the one that we didn't have time to get to in class last time. So this is just determining the value of a bond. So the value now of a bond, where we want to achieve an annual yield of 12%. The bond pays out $50 a month in interest for the next 5 years, and then it gives you a lump sum payment of $6,000. And so you remember from the exam that the two components of value in a bond are the return of principal, which occurs at the end of the bond's life, and then the periodic payments of interest. And so if we look at this formula here, it's saying there's something you need to do, a find P given F. So even if you don't remember the variables like C, R, and Z, you can kind of remind yourself what those mean by looking at what's in the parentheses, because you do know that system. You do know that find P given F means that there's some lump sum future value that you want to find the present equivalent of that. And so C is how much you're going to get in the future. So here it tells us that that lump sum value in the future is $6,000. So C is $6,000. So someone's going to give you $6,000 5 years from now. And by the way, this problem is monthly. So it says that you're getting interest in monthly terms. And so N would be 12 months per year times 5 years. And so there's 60 periods. And that's significant because the other part of the bond's value is the periodic interest payments. And so here in parentheses, find P given A, that's just a reminder that there's something, a uniform series that's being paid out every so often. It's the interest payments. And you want to find out what's the lump sum present value of those interest payments. And so R times Z is the $50 per month that you're getting in interest payments. We don't know what is the face value, and we don't know what is the stated rate of this bond, but we don't need to if we know in dollar terms how much interest is being paid out, and that's $50. And so there's 60 payments of $50. And what we want to know is we're trying to achieve a yield of 12%. So that's the annual yield. And so the interest per period would be 12% divided by 12, because we want to know the interest per period. So it's 1% per period is I. So this is find the lump sum present value, where if we're going to find the cash flow diagram, we're going to get these periodic payments of $50 until we get to the end, in which case we still get the interest and also the lump sum. So the uniform series is $50, and that continues through the 60th. And then there's also the lump sum of $6,000. Now we want to know what is the present value of that. So I'm going to pause for a moment. You've got the equation table here on the screen, and also hopefully you still have the paper from last time. So you're going to need to do the find P given F. So here's the find P given F formula. You're also going to have to do find P given A. So here's the find P given A formula. So calculate the factors for both of those. Let me make it just a little bit bigger. All right. So if somebody's going to give you $6,000 in 5 years, and they're also going to give you $50 a month, how much is that worth now if you want your overall rate of return to be 12% per year? Or in other words, 1% per period. That would be a very nice rate of return. So in order to achieve that return, you shouldn't pay them any more than $5,550. If you pay more than that, then effectively what that's doing is it's bringing down your rate of return to less than 12%. So that tells you what the appropriate purchase price is for the bond in order to achieve a yield of 12% per year nominal. That's nominal because 12% per year is not taking into the effect of compounding. And so the interest rate per period was 1%. So we'll have a couple more of these bond refresher in-class exercises. You didn't have a bond problem on the exam. Not yet anyway. You probably will on some future exam. So I want to give you a few more refreshers just so that you never forget how these bonds work. Anybody have questions about this one? All right. Anybody been to a food truck before? Yeah. I visited Portland, Oregon about a decade ago. I was blown away at the food scene there. They had 2 city blocks, like big city blocks, with nothing but food trucks around the whole block. In total, there was probably like 60 or 70 different food trucks, each one of them with really obscure, interesting stuff I'd never had before, like Georgian food and Indonesian food. And by Georgian, I don't mean like Atlanta. I mean the Republic of Georgia. So it was awesome, and I tried a lot of weird stuff while I was there. And I've always wondered, like, what's the economics of a food truck? You know, because you don't have to pay for a building. It seems like you could make a lot more money potentially. So let's look at a case study of what if you went into business for yourself selling hot dogs, which is a popular thing around here. What if you opened up a Disco Dogs food truck? And I did a little bit of basic research, and a pretty typical cost of a food truck is $85,000. And that's just including like a basic vehicle and some of the supplies that you need, like an oven and a generator and a cash register and so on. And so let's say that your all-in investment to get this off the ground was $85,000. And let's say that you're selling hot dogs on the order of about $8.50 per hot dog. That seems high to me. But this is an actual menu item off of an actual hot dog food truck, the Lucky Chucky for $8.50. So what are the economics of that? How many hot dogs do you have to sell to break even? I mean, the math, it seems like the math would be easy on that, right? $85,000, $8.50. Do you only have to sell 10,000 hot dogs and then you've broken even? Well, no, because you didn't buy the food that you're selling for free. You know, the hot dogs themselves have some cost, and then there's the labor expenses and permits and insurance. So the economics of it are a little bit more murky than just sell 10,000 hot dogs and then you're profitable. So we're going to look at some calculations related to recovering this initial investment. Like if you spent a big lump sum to get a project or a business off the ground, what does it look like over time as you recover your investment? And that approach allows you to answer the question of how long it's going to take to pay off your food truck. You have to predict the future, of course. You have to predict what people are willing to pay for the food that you'll sell. You have to predict what your cost of employees and materials will be. So there's some uncertainty naturally. But as long as we're making projections, we can estimate how long it would take to pay off the food truck. And as we do that, you can keep track of, on a year-by-year basis, how much unrecovered investment balance you have. So that's in italics here. This is an important phrase that you should be able to explain on the next exam. Those concept questions hurt a lot of students. It seemed like, relatively speaking, people were better at putting numbers into equations than they were at explaining concepts, and you need to be able to do both. So the concept of unrecovered investment balance is just the idea that when you spend a lot of money up front to start some new initiative like buy a food truck, how much of that have you not got back yet? So if you have been working a couple of years, it's possible that you haven't got enough profits yet to cover that initial investment. So we can track that over time, and we're going to learn how to visualize that graphically and then also how to calculate it using Excel. So here's that visualization. It's really important to understand the concepts here. I love to have students either interpret a diagram, or I'll give you a concept and ask you to draw the diagram. And so it could go either way on this one. You need to be able to draw it and explain it, or vice versa. So let's look at the vertical axis. Unrecovered investment balance. So if you spent $85,000 at time 0 to buy a food truck, then even though that's an outflow, you spent $85,000, this particular graph has outflows up above the horizontal axis. And so by definition, when it says unrecovered, that means it's money you haven't got back yet. So first of all, let's just get over the fact that, you know, this is above the horizontal axis and not below it. Fine, no problem. So that the height of the line here represents your initial investment. So for example, the $85,000 you spent to get started. Now look at what happens during the first year of operation. Here on the horizontal axis, it's saying year 1, year 2. So I want to first of all mention that here is time 0. Here is time 1. That tick mark, time 1, means after 1 year has elapsed. And so the numbering that they've got here is just saying the first year is from time 0 to 1. The second year is from time 1 to 2. So we talk about the first year, the second year, the third year. That's a duration rather than an instant in time. If I say time 3, that means 3 years after the start of the project. But the third year is the amount of time between time 2 and time 3. All right, so that's just another thing I wanted to explain. But look at the shape of this dashed blue line. Anybody have an explanation for why it's going up during the first year and why it has that particular shape? And if you don't know, it's fine to speculate. Go ahead.
Interest is compounding.
Interest is compounding. Right. So let's say, what if you borrowed money to buy that food truck? If you borrowed $85,000 to buy the food truck, the interest is accumulating. So how much do you owe to the bank? It's the $85,000 plus the passage of time is increasing how much you owe. So by the end of the first year, the amount that you owe has grown. But then what happens is, we're assuming the end of period assumption, when like all of your revenue comes in all at once as a lump sum. And so you buy down your unrecovered investment balance with that incoming revenue, which hits at the end of period. So each year you see R minus E. The difference between the revenues and the expenses is the profit. So if you were buying the hot dogs for $1 and selling them for $8.50, and then you sold 1,000 hot dogs, then that would enable you to determine the difference between revenue and expenses, and that is how you buy down the unrecovered investment balance. So you can use this thinking regardless of whether you borrowed money from a lender to finance the purchase or if it was your own money. Because if it's your own money, you could have been using it for something else, Like if you didn't buy the food truck, it could have been in a savings account, and if it was, it would have been earning interest. And so in your mind, you have some expected rate of return. So we would still have the growth of the unrecovered investment balance, even if we were starting with our own money, because we had outlaid a certain amount of money, and then there's the interest that we want to be making, and then the unrecovered portion of that balance decreases at the end of each year. So does anybody have any questions so far about this figure? Eventually, after a certain number of years, after n years, it finally gets down to 0. And we call that the break-even period. When finally you've gotten enough revenue so that your initial investment has been paid off. So the internal rate of return, which we've talked about before, remember I showed you a bunch of different figures that illustrated the concept of balance. Balance between inflows and outflows. The internal rate of return is the interest rate that causes the unrecovered investment balance to come to 0 at the end of a certain number of years, at the end of the study period. So there is some interest rate that causes the inflows, being the R minus E, that's your inflows, or the profit that you receive. Balance between that and the uncovered investment balance, that was the initial outlay. So I prime is some unknown interest rate that we have to solve in a lot of problems. If I ask you to find the unrecovered investment balance over time, I would give you an interest rate. But in other cases, you're trying to find what is the interest rate that causes break even within a certain number of years. All right, this is closely related to the concept of amortization. And this word has the Latin root mort. Kind of sounds like mortician, which you know is somebody who handles dead bodies, or I don't know. Amortization means the death of a loan. And so when you take out like a home loan, or when you borrow money to purchase a car, the bank or lender will give you an outline of what your payment is going to be every month, what's your remaining balance, and they even break up how much of your payment goes towards covering interest and how much of the payment goes towards covering the principal. And when I didn't understand amortization, I thought, well, how rude of them to assume how much of it should go towards interest and principal. I want it all to go towards principal. That way I'll pay off my loan faster. But it doesn't work that way, because if it was all going to principal, then you wouldn't be paying interest. And they're not going to loan you money unless you're paying interest. And so just kind of by definition, there is like a numerical approach that tells you how much should be principal and how much should be interest. It's not a matter of their preferences. They're not setting it up that way to be sneaky. It's just in order for a loan to be paid off, there's a certain distribution of the payment amount going towards interest and a certain amount goes towards principal. And you're going to go through the process of calculating that today. And so this is closely related to this figure, where we've just got some loan balance which goes up during the year and then comes down when a payment is made. Then it goes up and comes down and eventually reaches 0. That's the process of amortization. And so the column titles here are provided in a spreadsheet template that I put online for you. There's a new folder in Blackboard. If you go to Blackboard, it's got right now, I think, 4 different Excel files. One of them for today's in-class exercise, one of them for Mondays. But those Excel files are basically provided just so you don't have to type in all these column headers. It's just to save us a little bit of time. I don't think that there's any formulas in there. At least I don't intend for there to be. So what this allows us to do is just do the calculations related to gradually paying off the initial cost of an asset. All right, let me give you the paper for today's in-class exercise. And if you've got your computer, go ahead and open up that template file that's on Blackboard. So I give you the formulas that you should use, and look, on this handout, I've labeled the columns like column 1, column 2, column 3, and so on. So these formulas at the bottom are saying you find column 2 by multiplying the interest rate by the value in column 1. So I give you the formula that you should use to set up each of the calculations, and then I'm asking you at first to calculate what is the payment amount using this factor that I've provided. So the factor for find A given P at 4% interest and N equals 5, the factor is 0.224627113. And I've given you a lot of digits because I want your payment amount to be accurate to the nearest penny. So first of all, do the paper calculation of what is the annual payment you need to make. Not enough just to put numbers into a spreadsheet given like some formula that you're provided. that's not really understanding. Understanding is kind of breaking it down and understanding it. I don't know. Understanding is understanding. Not a very good explanation, but it's just being able to synthesize it on your own if the formula wasn't provided, or maybe understanding the significance of it. And so we know in this example with the hot dog truck, it's $85,000 was the initial amount. So hopefully that's obvious enough. Okay, 4% interest per year. And so even if you weren't given the formula, this is saying the interest this year on the unrecovered investment balance. And so you got the $85,000 at time 0. 4% of that is the interest this year. So I'm going to anchor the reference because I know I'll probably be dragging that down, and I always wanted to look at the 4%. So 4% of $85,000 means for the privilege of borrowing $85,000 from the bank, they want $3,400 at the end of the year. So in their mind, they gave you $8,500 at time 0. At time 1, you owe them the sum of those two things together. So the balance of the loan is the amount you originally took out plus the interest that's accumulated, but that's before the payment. So at the end of the year, just moments before you make the payment, that's how much is due. Now, what's the amount you give to the bank? We determined that with these the calculations here, where the find A given P, we have to pay it off at the end of 5 years by it being $19,093.30. So, why do you give the bank that amount? It's because otherwise it wouldn't be paid off at the end of the 5 periods. So that's why it is the $19,093.30. All right. By the way, I think the formatting to begin with was only showing the dollars. So here on the home ribbon, you can increase or decrease the number of digits that are showing if you want to show the cents in that 4th column. So any questions so far?
Will, showing how many, showing the cents of the amount, will that also affect your calculation in Excel?
No. No, even if they weren't visible, Excel still knows they're there if they are there.
Okay.
So that's a great question. It doesn't affect the calculations. It won't affect your grade. It's just really a matter of personal preference. I was kind of surprised how many of you on the exam left the formatting where it's negative, it's red, because I hate that so much. I kind of thought maybe, I want you to hate what I hate. That's kind of the point of having students and kids is training them to hate what you hate. So anyways, yeah, the formatting is currency, and then it'll avoid that the red and then the parentheses and so on. Anyways, all right, so the amount of this year's payment that goes towards principal. So this is what I always thought the bank was ripping me off. It's well, how dare they say that only a small fraction of my payment is going towards principal? But no, it's just a natural consequence of the fact that $3,400 of it is interest, right? Because that's 4% interest. So I made a payment of $19,000. The amount that didn't go towards interest goes towards principal. So the principal amount is the overall payment minus how much of it went to interest. So we could deduce that even without the formula that's being provided. And so the unrecovered principal balance at the end of the year was, here's the beginning of year unrecovered principal balance, and then we subtract, did I already do the equals? No. Equals this minus that. So 69,306. So if you were thinking in terms of this being your money rather than borrowed money, the approach would still be the same. All right. The end of the first year is the same thing as the beginning of the second year. That's the same moment in time. The end of the first year, if we look at the cash flow diagram, the end of the first year is right there where the cursor is. That happens to be the beginning of the second year as well. So down here, the unrecovered principal balance at the beginning of the second year is just that same thing from the end of the first. And then from there, we can now drag everything down without having to type the formulas in again. But pay special attention, because Excel sometimes, if it sees a number, it just increases it by $1 on the next one. So you might have noticed that your unrecovered principal balance went to like -6 instead of 0. It could be because of that counting thing. So the way around that is just copy the value and paste the value rather than dragging it down. If you drag it down, for whatever reason, it thinks it needs to be increased by 1 with each row. So if I drag that, it's done the same thing again. So let me just copy and paste, paste, paste to make sure that it's always the same payment value. And then I've got 3 cents left over because there's an odd number of years. I couldn't pay 3/5 of a cent at the end of each year. So being 3 cents off is the fine. Maybe what we do is that last payment we'd make it $19,093.33, and then we actually are in the clear on that last payment. All right. Yes.
It's kind of off topic. So if you did just have that 3 cents of unrecovered principal balance, the bank will be a stickler for that?
Yeah, absolutely. I've had banks send me a check for less than the cost of a stamp, and they expect the same. Like, it's just the accountants sit there and rock back and forth and just can't let it go until they get every last penny. So you got to pay the whole thing. All right, so you can use this same approach for finding the how long it takes to pay something off. This is basically all that you're going to need for the next homework assignment. So if we just take a parting look at the announcements here. All right, so Monday we won't meet. That lecture's already on YouTube, and I'll post the link to Blackboard just to make it easier to find. Homework 6 is due on Monday. That's 4 problems, if I remember correctly. Anybody looked at that assignment already? Is it 4 problems?
Yeah.
4, okay. And then the project is a long time off, but you're not going to procrastinate because you just want to get it over with early, have plenty of time to ask your questions. So that's it for now. I've got office hours now. If you'd like to stop by my office, I'd be glad to see you.